Okay, now we're going to talk about arrays. And arrays are just a data structure that can store multiple variables of the same data type. And when you start thinking about a data structure, it's probably easiest to first visualize what you're working with. So what is an array visually? Let's go to this website, excelvbasequel.com, and this is called a one-dimensional array. You could think of it as just a column in a worksheet, and each column has rows in it, but it's only one column. So this is a one-dimensional array, and all it is a column with three rows. One column with three rows. You could have one column with a million rows, but the point is a one-dimensional array is similar to one single column with uh, with with either one row or more than one row. And the array, all an array does is it can hold variables in each cell. You could sort of think of this like a cell in a worksheet. It can hold a string variable here, and it can hold a string variable here and a string variable here. But the array has to be of the same data type. So it's going to be all string variables in this array, or all integers, or all Boolean, or whatever. But it has to be the same data type. And the other thing to notice about arrays is that they have these indexes, what's called an index, which you can think of as the address of each element in the array. So in this case, we have an array that has an index starting at 0 that specifies the first element in this array. And the next element below it has an index of 1, and the next index below that has an index of 2. So you need a way to reference this data structure, and you do that by giving it a name. But just giving it a name won't really help, because you really need to know what address you want. So you really want to know what variable you want, and to do that you need to know the address of the variable, and that's why the indexes are important. So that's what an array is. It's just a data structure that can hold variables, and since it's a data structure that can be very big or small like this, you're going to need to be able to access the elements of that array, and you do that with an index. And what's really important to remember is that in Excel VBA, the index starts at 0. So you see this 0 here. It's not 1. So keep that in mind as we move forward. Now, you can have a two-dimensional array that will be more than a column. It'll look something like this, where you have a first dimension down here that goes in this direction from top to bottom, and a second dimension that goes from left to right. And you could think of this as like a table in an Excel worksheet. So now, instead of having just one column, you can have multiple columns. Up here, if you only have one column, you only need to reference the row. But now in a two-dimensional array, you can have multiple columns and multiple rows. So you need two indexes, one to reference which row you're in, and one to reference which column you're in. And arrays, I want to be clear, these things are held in your computer's memory. So when I say row and column, it's only to sort of give you an intuitive feel for what an array is. It's similar to rows and columns on a Excel worksheet, but it isn't. It's in your computer's memory, and it's just space that has an address attached to it and a name attached to it. So there's space on your memory with a name attached to it, and then that name also has addresses. and you can access variables at those addresses. So let's say in the two-dimensional case, you want to put something in row 2, column 2, right here. Or actually here. Yeah, right here, row 2, column 2. The address would be 1, comma 1 because the indexes started at 0. So row 2 is actually has an address of 1, and column 2 has an address of 1. So 1, 1 would get you to the middle of this table, row 2, column 2. You could even have three-dimensional arrays, and now it's a little bit more interesting to visualize because now you have 3 dimensions. One, I don't know if you could see it on this in your screen, but it's a cube. Instead of having a table, now you have a cube where you have rows and you have columns, and then you have a sort of depth dimension. So you have rows going this way. You have rows going, here's the, let's see, the rows go down here. So this blue number here is 0, 1, and 2. That's sort of the rows going down. The green number, 0, 1, 2, is sort of the columns going across. And then the red number, 0, and then 1 is like this second this second dimension, the depth dimension in the second address. So here's the 0, here's the 1, here's the 2 going in a depth dimension, and it makes up a cube. And now you need 3 indexes to access a variable in this cube. If you give me 3 indexes like 0, 1, 1, I can get to this cube and I could pull out whatever data is in it. Or if you give me 2, 0, 2, I can go back here and go get the data that's in this cube. And again, we're not talking about cubes like these cubes really exist. This is just a way to visualize what arrays are. They're just data structures. You could think of them like this. In reality, they're in your computer's memory, and all your computer has is a name and some indexes, and it can go find all these variables. The main thing to remember is that the indexes for each dimension start at 0. So up here in the first dimension, the index goes from 0, 1, 2. In the second dimension, now you have 2 indexes, one for the first dimension and one for the second, and both of them start at 0. And then even with a 3-dimensional array, you have 3 indexes that all start at 0, 0, 0, 0, and then there eventually you would get to 2, 2, 2 somewhere down here. Here's 2, 2, 2. But they all start at 0. So that's how you visualize an array. They shouldn't be too confusing. Just like I said, you can think of them like this, like as a single column, as a table in a worksheet with rows and columns, multiple rows, multiple columns, or as a cube. The main point is to access each element, you need an address, and the addresses start at 0. So now that we know that, we can go into Excel and we can write some arrays, or we can create some arrays. So I have a module here called arrays. I'm going to write sub static array, and now I can declare an array by doing this: dim names, just like I would declare a variable as string. So this would declare a string variable, but now I want to make it an array of strings, of string variables. So I do that by putting parentheses next to the name and then putting what's called an upper bound in the parentheses. And that is a static array. And why is it called static? It's called static because the size of the array, which is determined by this number, the size of it doesn't change. So that's all that static means. It just means the size doesn't change. But let's talk about this number. This number in parentheses is called the upper bound of the array, and the upper bound determines the size. So whatever you put in here in parentheses is going to determine how big your array is. In this case, if I put 2 in here, it means I'm going to have 3 elements in the array, because I should have said this a few seconds ago. The upper bound is just the largest index in your array. So in our case, if I put 2 in here, that means the largest index is going to be 2, which means I'm going to get an array that looks like this: 0, 1, 2. It can hold 3 things. So if I go into Excel and I look at the array in memory using the locals window and I step through, the names is in the locals window. This is the array. Notice over here it says names is the expression, that's the name of the array, and the type is a string, but it has in parentheses 0 to 2. That 0 to 2 is the address, the indexes, the range of the indexes, 0 to 2. And now if I open it up by treeing into it, I get names 0, names 1, and names 2. Well, that looks very similar to what I have here, only I don't have a name next to it, but I have the index 0, 1, 2. So what I just did is sort of declare this one-dimensional array in Excel, and I called it names. So if you give it a name and you give it, you put parentheses next to it and you pass in an upper bound, or also known as the largest index. Notice the largest index here in this array is 2, which matches my upper bound. If I change this to 20 and now step into it, now I have 20 string variables, each that has a unique address that starts at 0 and goes to 20. That means I have 21 string variables. If you only wanted 20, you would have to put in 19. Why would you do that? Because now you get a data structure that's called names, and it's an array of string variables that has an address that starts at 0, increments by 1, and it goes all the way to 19. And you could put strings in here. Notice they don't have any value, but you could, if you want, you could put strings in there. And now let's go to 2 dimensions. So let's try to create this data structure down here that holds 9 things. 1, 2, 3, 4, 5, 6, 7, 8, 9. It holds 9 things, and it's real easy to do that, to create a 2-dimensional array. You just put the size of the first dimension, or the upper bound of the first dimension, and then you put a comma, and you could put an upper bound of the second dimension. Remember, the upper bound is going to be the maximum index. So if I click into this now, notice it says the type is a string and it's an array, and the first dimension goes from 0 to 2 and the second dimension goes from 0 to 2. And now if I tree into this and I tree into all these things, I have my 9 elements here. Just like I have my 9 elements on this website that's very intuitive to understand. I have 3 rows and 3 columns. I have the same thing only on the computer's memory, and you could see it's name 00, name 01, name 02, and then names 10, names 20. All the same addresses that you see here, they exist in your computer's memory now. So you can put strings at each of those elements, and you could access them using the address. And you could even do 3 dimensions, but it's not usually done. You don't usually do 3-dimensional arrays. I mean, it could handle it, but it gets very confusing. And now you see the same thing, 0 to 2, 0 to 2, 0 to 2. And now if you tree into this, look what happens. Same sort of idea. Let me try to expand this. Now you have your elements that each element has 3 indexes, like 3 numbers in its address. And I could expand the rest, but you should get the idea now, is that this is similar to what we see here in this visualization. It's like a cube. It can store 27 things. You know, here's 1, 2, 3, 4, 5, 6, and then 7, 8, 9, and then there's another 9 things here in the second dimension, and another 9 things here in the third dimension. And you could see that here. Well, actually, those 9 things are not separated across dimensions. It's the combination of the 3 dimensions that creates the 27 elements, and you could see that. So name 0, 0, 0. That's equivalent to what you see here, like this cube or this square in this bigger cube. You can put a string in there, and you could pull it out. You could pull it out by giving it the right address. So now let's do some very simple stuff here, just to show you how you can assign to an array. If I go back to the simplest case, just a 1-dimensional array that can hold 3 things. If you want to put something in that array, you can put a string in there, and to do it, you would reference its address, like names1 is equal to hi. And now if I step through this, and I step through that code, look what I have. This value, hi, is assigned to the string variable in the array at that particular address. It's assigned to the variable at address 1. So this, whatever you put in the parentheses, when you go to assign to it, it's going to be assigned at that address. And then if you want to access that, you do the same thing. You could do like message box names 1. And the reason I did 1 was just arbitrary. I mean, I could have set this to 0. So if we step through this now, I assigned the value hi to this element in the array, and now I want to access it. Well, all I need to do is use it like this, names and then 1 in parentheses, and now it'll do a message box and it'll go hi. So you see now that an array is just a data structure that can store variables of the same type. They're all string variables, and the size of the array is determined by this number, which is called the upper bound, which is going to be the largest index in the array. Notice here's the largest index, it's 2, and that's what you put in here. It's called the upper bound. And when you want to assign something to it, it's very simple, just like a variable. You just need to provide the address in parentheses of where you want to assign it. And then when you want to access it, you just provide the name of the array, and then whichever element you want to access, you can just put the address or the index in parentheses. So those are the arrays. Now, I just told you that the indexes start at 0, and this is common practice in VBA that the indexes start at 0. If you want the index to start at 1 instead of 0, you can go up to the top of your module and you could put option base 1, and now when you click through, because I put this up here, option base 1, look what happens. Now the index starts at 1. So that's all option base 1 does, is it changes the index from starting at 0 to 1, which um, is going to affect the size of your array. Before, when I didn't do option base 1 and I put 2 in here, I ended up with 3 elements. I don't think I need to go through it, but I ended up with 3 elements. Now, since I put option base 1, I only end up with 2, and that's because before I had 3 because the index started at 0, so I went from 0 to 2. Now if I make it option base 1, the index starts at 1, and I go from 1 to 2. But this is still going to be the largest index. Whatever you put in here is still the upper bound. It's still the largest index in your array. It's just that this can change the starting index from 0 to 1. So that's an option. I don't do it just because, I don't know, it doesn't bother me. If it bothers you to know that, if we step through this one more time, if it bothers you to think that the size of the array is going to be 2, but then you look down here and it's 3 because the index starts at 0 by default, then go ahead and put option base 1 at the top, and you'll better understand your arrays that way, the sizing of your arrays. So I'm going to put up some example videos next. We're going to go over some examples of how to use arrays, and they're very useful in your VBA programming because now you can store many variables in one data structure and access them or assign to them, and we'll look at that coming up.